Okay, test one, audio test one. Anybody in the chat? I should be audible now. Okay, if you're in the chat, welcome. Welcome to the chat, all 5 of you beautiful people. Hey, thanks App Pack Limited. Thanks for your confirmation there. Getting hyped for the next Battlecode lecture. Oh yeah. Mm-hmm.
Somebody's having a good time.
You know, I think I was going to try and tell them to keep it down, but when somebody's having that much fun, it just seems wrong to tell them to be quiet. I'm not such an old curmudgeon that I can't appreciate that they're having a good time. Hello. I haven't heard of anybody lecturing with me today. That's quite all right. Hello.
What are you going to lecture on today?
I've just got some examples.
Nice.
Any particular ideas?
I talked to like one person in my dorm who was doing it, and she's like, for beginners, like her feedback was that like she understood all the pathfinding stuff but wasn't sure how to apply it, and it's like maybe writing a bot or like examples of like actually writing stuff for the bot would be helpful. That was just feedback from one person.
One person's better than 0 people. So that's what my examples are.
Cool.
They're doing Battlecode stuff. I was wondering, I don't know if you answered the question on the Slack because I didn't
Maybe not.
still have it on, but it was about does snipe work for sure?
This might work for sure.
Because I tried to make a bot that does snipe, and it didn't seem to produce damage. Like you could call the method, but it didn't seem to damage anything. I didn't extensively test it, so.
So is it like you waited a few turns and then didn't do anything?
I made a print statement when it tried to snipe somebody, and the print statement came out, but I never saw anything getting damaged.
So I'm not sure if this is how you're interpreting it, but Snipe has a countdown rather than a delay.
Yeah, so I've tried waiting the whole duration of the match.
I haven't extensively tested it, no, so it's very possible it's just broken.
Okay, well maybe I'll make like a short demo player, and then, because after all, you could just tell it to attack itself,
Yeah.
and then see if it loses hit points.
Okay.
So I can write a demo player at some point to test it,
Thanks.
and then we'll see. Yeah, I think you could snipe yourself because you're sniping a location.
Okay.
So anyway, I guess if you don't know about it, I'll check it, and then if it is a problem, I'll let you know. And it's probably me. I don't know. I couldn't figure it out.
Did I tell you about the random game mechanics that are possible?
Yeah, so I feel like if you add in games, probably doesn't make it much easier.
As long as he doesn't
But it will.
write that you were some totally dependent on like a new field.
I think if I did this, it's probably going to be different on the replays.
It's fine when he changes that on the whole outcomes of like split change. I think that's just what he's talking so all the replays in general force from something that says, for instance, the units of those always be used in the future.
Yeah, that's what I'm trying to like if you any change the menu beforehand.
Gotcha. Yeah. Yeah, I can do that. I don't think I did fix it actually.
Yes, if you decide that.
I can do that.
I think I can do it all the time. The ship order is going to be like several $1,000, so I'm definitely not doing
base points. Yeah, $5,000. It'd be ridiculous if we do a customer.
Will the map always have a portrait infantry rotation symmetry?
No. Horizontal and vertical reflection symmetry are also netted. I think just so far. Probably not. Anything goes. The whole map is visible to you at the start, so you can at least work it out fairly easily.
Well, not really. If it has all horizontal protection symmetries, then you can't tell which one it is.
Sure, but then it doesn't matter.
It does.
Why?
Where which direction do you go? If a square map and you're at one of the corners, which direction do you go?
Well, you can see everything anyways. Like, if what type of symmetry the map has isn't as important in past years, isn't as important as in past years when you need to infer the symmetry type to actually work out, to infer things like that. You should know the starting locations.
Okay, starting location is fine.
So you get all of the workers' starting locations and all of the initial like terrain. So the only part of symmetry is to make sure that none of these is matched.
If there isn't a method for that in the API, there should be.
Okay.
Yeah. Technically, the symmetry deadline isn't an hour. Which I think it always goes without saying that that's not happening.
Stop.
Okie doke. Welcome, everybody, to the Battlecode lecture. How y'all doing? Good. In today's lecture, we're going to look at some examples that I've written. They're not very good, but you might learn something. I certainly learned something writing them. And so I guess we'll just get right into it here. Let's open up a match using the old player that we did last time, just to get started. So we'll do lecture player versus lecture player on socket.bc18. And let's run that one and see what that looks like. Okay, so this is the player that makes a couple of factories, it does some mining, it produces some knights, because I thought they were a good unit at the time. I don't think they're a good unit anymore. But this was the Gandhi player as well. The knights just surround the enemy, and it prevents them from building anything, because you occupy like all the tiles where they would unload. It doesn't even work that well at doing that, because you bobble around and then they get guys out in the little spaces that you leave behind. You'd have to really pack in well to prevent that happening. So overall, this player needed some work, and so you can see here, that was lecture player. And now I've got 9 more versions of it, because more versions means more progress? I don't know. How we doing in the chat? We got 22 people visiting and watching us remotely and not making very many comments. Okay, sounds good. So I'll go to the next one here, lecture player 2. So the new guy I'm going to make in blue, and let's see how version 2 does. I wouldn't say that I compromised on my principles in number 2. You know, I still am fundamentally in favor of nonviolence, but in the context of Battlecode, I think you'll see that blue has a different idea about how to bring about a peaceful solution. So the blue Ks down there are unfortunately dealing damage to the red, the harmless red nonviolence. And I think it's just a fact of nature that, at least in Battlecode, the teams which do the most damage are probably the ones which are going to make it ahead. They're probably going to do pretty good. So I'm going to use this tiny viewer that one of the competitors came up with. I should credit him. 1 second, I'll credit him. Anthony, yeah, this is Anthony. I guess he's up there at the top in the URL. Anthony Bao. Thank you for making this viewer. I like it. I like it, and I'm just going to use it for simplicity here. So let's look at it on that viewer. I'll just scroll ahead. So yeah, you can see in this viewer that the blue dudes do in fact hit the red dudes until the red dudes can no longer take hits. Okay, so that's pretty one-sided. And then I thought, all right, well, what do we do next with this? How can we improve further? You're going to follow my little path. So now the red player will be player 2, and the new player will be lecture player 3. Okay, so then we'll see how version 3 has improved. I mean, after all, it's a pretty big improvement going from not attacking at all to attacking somewhat. And I'll show you what these numbers are as well, that these players are printing out. So in this case, both teams are attacking, and in fact, you might not even be able to tell the difference between the two, because despite the amount of effort that went into it, they ended up being about the same. So so let's look at, this is run.py for lecture player 3, and we'll look at it while the match runs on the left. So what is the difference? I believe this is the only difference. I just queued research for the red, is it the red team? No, the blue team has research queued, and the red team doesn't. So, so yeah, they both have pretty much the same code, and we'll go through what some of this does, because it might be of use to you. But see here at the beginning, if gc.planet equals bc.planet.earth, and then it starts doing something, and here's the other version of that, and it's got the research queued. So the workers are going to end up mining 1 resource per harvest more, which I guess is a 33% improvement. And that only takes 25 rounds to research, so I threw that one in there. And then we've got all 4 knight researches, which the first 3 increase the defense, and the last one gives you the javelin ability, which I haven't even coded in. But I wanted to see if these research advantages are actually sufficient enough to like cause one player to definitely win over the other one. You know, like how important is that? And if you look at the specs, let's go to battlecode.org here. I always like theory crafting with the specs. I don't know if anybody watches Spirit of the Law. Anybody watch Spirit of the Law on YouTube? He likes to, sometimes he'll point out that if you get a little more defense, then you can switch from taking 8 hits to taking 9 hits before a unit is destroyed. And doing that kind of analysis is what we're going to look at for a second here. So how many of you have already done this like calculation? Almost none. So it's worthwhile. Either that or you haven't done it because you didn't think it was worthwhile. Okay, so let's look at max health. Knight has 250 hit points, and it does 60 damage. And on the knight tree, you see that if you get these 2, then you get more armor. So you can get up to a total of 15 armor. So it would be 5 with no upgrades, 10 if you got this one, and then 15 total if you got that. So 15 armor would make another knight, instead of dealing 60 damage, would deal 45. So in one case, you have well, they would never do 60. It would be 250 hit points divided by 55 attack, which would be 5 hits to kill. Or in the best case, 250 divided by 45, which would be 6 hits to kill. So not a huge difference there. And every match naturally has, oh, it ended, so we'll have to watch it using the viewer here. I use Control-R to reset it. I don't know if there's a smarter way to do that. So we'll watch the match again in ultra speed here. So the blue guys are the ones with the upgrades, and you can see that here. The upgrades are indicated on this viewer, which is another nice feature. Although upgrade number 3 isn't indicated. I don't know why. I feel like it should be. Okay, so these guys sort of swung around the side. There's always a bit of like instability in these matches, probably because of you know, one team gets lucky with its placement. So if blue won, and we can say, oh, they won because they have the better upgrades, it's probably the most fair for us to repeat the match with the players switched. So now red is going to have the better upgrades, and we'll run the game again. That'll give us an opportunity to look at the code a little bit more closely, because there's some things that this is doing that you may want to repeat. Did I already talk about this part about inverting the map last time? Where you can guess your enemy's location? I can't remember. I think I did, yeah, because the knights in the first player I wrote, the knights went to the enemy location. So that's this part here. I just take the first, I look at all my units, I take the first one out of that list, and I get its location, and then I invert that using this function invert, which I wrote, which just subtracts the width and height from those numbers so that you get the opposite side of the map, just as an estimate for where the enemy might be. That's not that exciting. Here's a more exciting part where I'm going to start storing the map locally, and I start jumping into the question of how do I optimize and save the most time. And if you want to pay attention to this on the left instead of paying attention to me, that's okay. I recommend it. I'm not that entertaining. The red guys this time are the ones with the upgrades. So we flipped it around to see if they would win. And I guess we'll keep that going while I talk on the right. Hopefully the picture of my head isn't hiding the screen too much. Maybe I scroll down a little bit, and that'll help for people who are watching that way. Okay. So the first thing I do here is store the map locally. And you might say, well, what's the point? I can just access it from, which one is it? Which part gets it? It's up here. Earth map equals gc.startingmap. And what I do here is I'm assessing the difference between storing it locally and accessing it again and again, just because I want to quantify how different that is. So I'm using time.time. So if I import time at the top, you see it's there next to import OS, then I can use this time.time function to get the current time. So I'll do something like access start equals time.time. And then I'll perform an operation. And here I perform the operation 10,000 times because I found that when I only did it once, if I subtracted the access end time from the access start time, then the difference was so small that when I printed it, it came out as 0. So instead, I've done this access 10,000 times so that I can try to see what's going on. In the first case, I access gc.startingmap.isPassableTerrainAt, and my claim is that when I make this call here, that the Battlecode game engine is copying an entire copy of the map object and then giving that to me. And then I'm using it only once, and then the garbage collector throws that reference away. So that 10,000 times I have to generate new objects here. Even if I'm not generating it in my code, the fact that the Battlecode game engine is doing it will cost me time as a player. That's the theory, and I'm testing it by using this access start and access end thing, and then I'll print the text, accessing x 10,000, the GC map took, and then I'll turn into a string the difference in time in seconds between the end and the start times, and then I'll put a little s to indicate seconds. So I print that, and I do another access test here. In this case, I've stored the entire map into this passable map object, which is an instance of the class mmap, because I'm so good at naming things. So I named this mmap, and it's a 2D array of numbers. It initializes with zeros in it. So here in this notation, I make this 0 as high as the height is, and then I use this list comprehension just to make it as wide as the width is. And then I go through and access all the elements out of the GC map, and I dump them into this map by setting self.array at x and y is equal to a given value. And I provide the convenience function set and get so that I can supply my little map function thing here, my map object. I can give it a map location to get an item out or to set an item into it, just for convenience. I've also got a printout function, and you're going to see the results of that printout. And one thing in this might look weird. It's that as I'm printing it out, I access the elements in opposite y order. And that's because if you, in Battlecode, the lower left corner of the map is 0, 0. From your perspective, this is 0, 0. So if I'm going along counting from 0, 0, and I start printing this line first, and then this line, and then this line, well, the print things appeared, the things which are printed most recently appear at the bottom. So you have to flip the y-axis when you go to print into the command window. And that may give you a little hint as to why old computer programs and many computer graphics programs use this corner, from your perspective, as 0, 0, rather than this corner. Okay, so it builds a string, and then it prints it out. That's kind of obvious. So I make this local map copy, and I bet you're all just like on the edge of your seat. You can't take the idea of not knowing just how much faster it is to access the map that's local. See this passable map guy? Here's the part where I set it. I set it equal to is_earthmap.isPassableTerrainAt at this location, and then I access it using the same access location notation. So comparing 10,000 times with the GC map and 10,000 times with the local map, who thinks that that they're the same or close enough? Now, who thinks that the local map is like faster? Who thinks it's like way faster, like a killer thing? It's like tons. Was that it? That was up from before. Okay, so we got some like little bit faster. I'm not going to spit out my milk in surprise, kind of faster. Okay. Well, I've built the suspense enough. Let's look at the output here. I think I can just look here, and it says here, accessing x10,000, the GC map. Remember, it's 10,000 times. Took 110 milliseconds, and accessing x10,000, the local map, took 60 milliseconds. So to me, that's, it's a big difference, but it isn't killer. It's not unbelievable. I don't know. It's not that much.
Probably caching.
Probably caching. So the suggestion there is that something behind the code is being smart about what it's doing, and it's not dumping the reference to that thing every time. And that so at some level, it seems like you don't have to. I think the lesson to be learned from this is that if you find it easier to program a certain way, maybe your time is better spent understanding the strategic layer of Battlecode rather than optimizing things that don't need optimizing. Or maybe there's no lesson and it's just a data point. Just a data point. Okay, so I love these little map printouts. You can see this one is a printout of the traversable terrain. And so there's a bunch of ones in places where it's traversable and zeros where it's not. I hope that's clear what it looks like. And you might have noticed also that I put a little space between each number. And that's because I think in Unicode, or in rather the monospace fonts, they're taller than they are wide. And so a good representation of the map, in my opinion, has a little bit of space, and that also accommodates the printout of the locations of carbonite, which can sometimes be 2 digits. So you can copy my map printout function. You might say, like, map printout, Battlecode's got nothing to do with map printout, but I propose to you that if you're trying to debug, like, your pathing code or something, and you need to know what a robot's internal representation of the map looks like, printing out some kind of copy of that map may be like a really good idea. I think it's a really super good idea. So I'm just going to point to this again. So yeah, you can just copy my printout function. I'll have posted this code online. And I just build the string and I use a format, quote 2D, end quote. And that makes it have two characters per position. Okay, so we looked at storing data in these mmap things. And you might say, well, it's not worth it, so I'm not going to bother with this internal representation of the map. Later on, we're going to add more things to this class, operations which we'll do that are specific to that 2D map of information. And so even if it isn't worth it now, it might get worth it later. And then the next thing I do with this code is I generate an ordered list of the carbonite locations sorted by the distance to the start. So I thought, you know, you can have your workers go at random in random directions to try to find the carbonite, but you kind of know where the stuff is. Like, you're supplied with that information at the beginning. You see here, where is it? So we've got an earth map, which is gc.starting_map, and then at the same time as we're setting the values of the passable map, which is this one here, we're setting the values of the k map, which is here. We do kmap.set at the given map location, earthmap.initial carbonite at map location. So we can get those initial values, and knowing what areas of the map are passable and where the carbonite is at, we can generate a list of the distances of those things to the starting location. And you might say, well, that's a really good list to have. Or at least I thought so at the time. So here's how I did it. And I also quantified the amount of time it took to do it. So you can see here it says generating k-locks, that's this list of locations where carbonite is located, took 0.038 seconds. I think that's a pretty modest amount of time. I mean, you've got 1 second to start the game. Your pool of time starts with 1 second, and you get an additional 50 milliseconds per turn. So I feel like spending 40 milliseconds at the very beginning generating an ordered list of these K locations is not bad if it prevents your guys bobbling around and never finding this stuff. So how does it do it? It generates a new map here called eval map. And the purpose of that is because I'm going to do the same thing I did with breadth first search, where I started from one point and then I evaluated points going outward from there, because that naturally generates a sorted list of how far things are from the center. The ones you hit first are the ones which are closest to the center, and the ones you hit later are farther away. And of course, when we talk about distance now, we're not talking about the distance as the crow flies. We're talking about the distance that you'd have to walk to get there, because that's what matters to the workers. So I start by generating an eval map here, which initializes to 0 in every location, and then I'll be using that to store information about whether I've accessed that tile already, and that prevents the spread out thing from spreading back in on itself. Then for each unit, I go ahead and append to the current locations that location starting point, because after all, I want to know the distance from everybody, and if I've got a worker way over here and a worker way over here, well then they both have their own little pockets of what's considered close. Then for each location in the set of locations I've currently got, I check each direction, and if the eval map shows that I haven't been there before, I'll indicate that I've been there before with eval_map.set new place 1. Then I'll append to the next locations list the new place which has been added, and so like this I can generate this list, although I think maybe you can already guess what's wrong with this way of doing it. It didn't occur to me that this would really be an issue. Maybe you guys can guess. What's wrong with generating an ordered list of where the carbonite is and then telling the robots to access that list one element at a time? Well, I think the problem you're going to see. So in this version, it says here, yeah, it's using the carbonite locations. So that's in lecture player 3. So we're going to put lecture player 3 versus lecture player 2, which we just did, and we'll go ahead and load that file here. So let's choose the file and this one. All right, so 3 is the one that does the upgrades, and it should also be, see these red workers here? They're mining the locations which are closest to the start, but at some point they'll give up on this block here, and now they head over to here. Watch this. Well, in theory they do. Yeah, so now they're heading over to there because now this stuff is closest to the starting locations, because if you reset, you might recall that we had guys starting on the right and guys starting on the left. So they end up bobbling around, taking a little munch out of one side and then a munch out of the other side. And in a way, that's kind of inefficient because they're spending so much time walking. See this? Walking between the two piles. So even though it's nice because they're going to get to the end and they're going to ultimately eat all the nummies, it's not perfect because it's not efficient. Okay, so that was the idea behind identifying a list of locations where they want to go to. It didn't turn out too good, but I want to point out that doing something like that is not necessarily a bad idea. I want to propose the following idea, which I haven't implemented yet, but which I think is such a good idea that it's worth proposing. I'm going to make a screenshot of this, and then I'm going to operate on it in that holiest of holy programs, MS Paint. Okay, and then I'll just make this nice and clean here so we can just focus on this. I really like the idea of isolating the map in a more coarse way, because what we did there is we made a list of locations which were good to go to, but those locations were too fine. There's hundreds of them. In a map that's filled with carbonite at every location, that list would be, 10, if it's a 50 by 50 map, then that list would be 25 elements long. And even if you are only accessing the first element, it seems inefficient to consider all those little points when really what you care about is regions of the map. And so what I'm drawing here is an idea where you would coarsen the map. You'd say, okay, let's add up the carbonite in each of these regions and say, okay, let's consider a region to be visited if we've mined up, a good amount of carbonite in that region. Or let's consider a region to have enemies if it's got more than so many enemies in it. And I think if you were to set things up this way, it would also make it easier to debug what your player is doing at any one time. Because your player you could clearly see if it was located in a certain tile, or if it had eaten all the goodies in one tile or not. So you could use the same sort of setup where you identify which tiles are worth going to using sort of these chunks. Even if you choose the chunks kind of arbitrarily, it might turn out okay, unless of course you choose a chunk and there's a barrier right in the middle and your guys can't ever get to the middle of the chunk. So maybe it's not such a hot idea. Advantages and drawbacks. We'll move ahead and look at lecture player 4. In this case, basically the only change I did is instead of making knights, I switched and started making mages, because I thought, how would they do against one another? Let's give this a try. That's what I wanted to find out. So we'll leave the red player as lecture player 3, and we'll make the blue player lecture player 4. And let's just see how that turns out. So blue is the guy who can make mages, And so you can see they start by making 10 workers. I just set that limit arbitrarily. Maybe it turns out you do much better if you make more than 10. But at the same time, I'm telling my workers to all contribute to the construction of factories. So if you make, 10, you can't even fit 10 workers around a factory that you're building. So making more than 10 with this particular algorithm probably isn't too good. Maybe you'd then want to split off. You'd have a team of workers for building and another team explicitly for mining. So yeah, you can see that the mages actually tear apart the knights. I don't know if I lost even a single mage in that game. Let's do a refresh here and watch it in this viewer, because I think it's a little easier to see. This viewer shows the attack animations as well. If you're just coming in or you didn't know about this lovely viewer that Anthony Bao made, you can either type this in or you can see the link to it under Materials, Competitor Resources at battlecode.org. So moving ahead, yeah, so here's the part where we mine stuff. Okay, now here's a mage, this guy, and you can see that as they shoot at the enemy disappears, which I think is a good thing. So the mages are pretty darn overpowered. And my next question that I had was, well, if the knight is no good and the mage is pretty good, then how is that next unit that we've got on the list here, the ranger? So I'm pretty sure that if we look at lecture player 5, pretty much the only difference I made is I pasted in this new bit of code, which checks if we've got a ranger and then tries to attack that. But there might be one other difference here. Let's just check and see here if the factory is actually building rangers or not. Because I had a bad habit of I would edit this and then I would... Never mind, I won't talk about it. So let's see here. Mage, is it still building mage? Yeah, so it's still building mages. The difference between lecture player 5 and lecture player 4 is that lecture player 5 is attempting to do something very smart with the targeting. Okay, let's run that. Let's run that now. So I think this one was trying to answer the question: what effect can we have? I think I need to restart the manager. It seems like it's not running. What effect can we have on the outcome of the match if we take into account that our splash damage can damage more than one enemy unit? Because after all, there might be some clever way of positioning your attack so that you're doing the maximum amount of damage, taking into account the fact that you can hit multiple adjacent units. So first I'll show you the outcome, and then I'll go back and we'll look at the code that produces it. I think this was lecture player 4 and 5, so in this case the blue player will be the one with a theoretically improved capability to target enemy units in clumps. So both teams are going to be building mages, because at this point in my experience of Battlecode, I thought that was a really good unit. I think maybe now I think the ranger is better. I'm not 100% sure though. Might have to do with how it's used. So you can see that both teams are building mages, and remember the blue team is supposedly much smarter about how it uses them. It has an algorithm where it checks all the adjacent tiles around where it might fire, and it assigns a point value of -1 if an ally is adjacent and +1 if an enemy is adjacent. And then it just shoots the tile that has the highest point value. But you can see the blue player lost anyway. In this case, I don't think it really makes much difference whether you super intelligently calculate what the best tile to hit is or not, because you're not allowed to shoot empty tiles as a mage, and because I guess neither team is being particularly smart about its positioning. If two enemies come at you and they're adjacent to one another, it doesn't matter which one you shoot at, you're going to hit both of them if they're adjacent, and you're a mage because you deal splash damage. So then being smart about what you're aiming at makes no difference. If somehow you get in the case where an enemy knight or mage is immediately adjacent to you, and you want to be super clever, like look at this here. I'm going to illustrate it in paint again. I'm sure you've all thought of this possibility. This is me, the mage, and this is you or somebody. Let's make it somebody else. This is the enemy in red, and of course he's right next to me, so I can't, if I hit him, then here's my attack pattern. Yeah, if I hit this guy, then I'm of course going to get hit. The smart thing would be for me to target the tile behind him, right? And this has been possible in earlier years of Battlecode. It's not possible in this year's Battlecode because you're required to specify a target unit ID that you're shooting at, not a target location. So unless the enemy is dumb enough to situate another one of his dudes back here that you can target, then you're unable to target that guy, and this one who's right next to you, you can't do anything about. Who came across this and thought, drat, I can't do that thing I wanted to do? Well, maybe it was just, yeah, I found one person. Yeah, okay, so anyway, that's a thing. So what I had to do to calculate those numbers for which tiles were, these, in this case, I only print out the map of that firing. This is the firing solution map, which indicates how good or bad it would be to fire at a given tile. And I only print it out on round 45. I think this is a really smart thing. Maybe it's actually dumb, but I think this is a really good idea. So if you've got some map that you're calculating, see, here's the while true loop that runs every time I have a new round. It prepares a splash firing map, and if the gc.round is 45, then fmap.printout. And that means that I don't end up, like the match doesn't take 1,000,000 years to compute because it's spending all its time printing out the map. But I get one of them, so I can have a look at it. I think this is a nice way to do it. Just print it out on one turn. And in this case, what it prints out looks like this. And you can see that I've cut it down because I did two things. First, I generate two maps. One I call the F map, which is like the firing map. It shows how many units would be hit, like the value of the units that would be hit. And then I've got the U map, which indicates whether a unit is present. So then I go through for unit in gc.unit, so that gets allied and enemy units that are in vision range. And if it's not in a garrison, then I'll set its team to choose the amount. If its team equals my team, then amount is -1, so that gives me a -1 penalty for firing in a location that would hurt my own dudes. And else, else I set amount equal 1. Then I set fmap.addDisk. So I made a function for my mmap class, which you can see up here. So here's mmap, and it has the method addDisk, which takes all the locations within radius squared of a given map location. And if those locations are on the map, then it sets the value to itself plus that number. So it allows me to do things like add disks together. I didn't put an example of adding disks. Yeah, this is an example of adding 2 disks to a map. So here's the blank map, and I added a disk of 1s here and a disk of 1s here. And those 2 disks form these rings. I don't know if you can see that clearly or not. You kind of have to squint. There's a certain magical effect which occurs when you're looking at a page full of numbers and then like certain numbers will just pop out at you. Has anybody ever been flipping through a book and you were looking for a number that was like a digit, the Arabic numerals, and then boom, they just pop right out at you? I don't know. The human mind is a lovely thing. And so here, hopefully, your human mind is capable of discerning this ring and the 2s in between them indicating the middle space of the Venn diagram. So this illustrates the function of this addDisk guy, and now you can see that what I've done later is I'll just use addDisk, but instead of making big disks, I just make little boxes, which are really circles of radius squared 2. So I make boxes, and I add up all those numbers, and then I go by and I have to trim them down because you can't shoot in a location that doesn't have a unit on it. So what I do then is I go by and I set umap.set unit.location map location 1. So I go ahead and set the value of a second map to 1 wherever there's a unit, and then at the very end I do fmap.multiply umap. Now you might think this is just way overcomplicated because you could always just have said, when you're trying to set the value, check if a unit is there. If a unit is there, don't set the value. And then it achieves the same result. Because after all, in programming, there's always like 10 ways to get the same result. Or maybe there's even an infinite number of ways, and you could probably prove it mathematically. But what I want to point out here is that this is effectively a masked map. So the mask is zeros everywhere except ones where there are units, and then the underlying map has information about where you want to go. And when you mask them together by multiplying, then you're left with just the information that you want. So you can sort this map, and that's what I do later when I tell the units where to fire. I sort this map, and it says if you find any tile within your attack range with a number greater than 0, so you can see a bunch of negative numbers here, that would be shooting on my own team. So that would be especially bad right here in the middle of them, and not so bad on the edge, but still worse than no shooting at all. And then for numbers greater than 0, then those are worth doing. So here's a 1, and in this map you can see there's 2 2s, which is just like a tremendous amount of programming and computational and thinking effort to finally identify the idea that if you only have a couple of enemies, a sparse array of enemies to shoot at, it doesn't really matter which one you shoot at. Other things are going to end up mattering substantially more. So the next thing that I do is I say, all right, I can't make one of my mage players beat the other by firing smarter. Although it's possible I could do it by a different route, but that was the route that occurred to me first. It's since occurred to me that there's the following theory craft. If life were mage versus mage only, then the following theory crafting is possible. Look at this. The mage maximum health is 80. Its damage is 60. However, if you look at the tech tree for the mage, it says the first upgrade gives you 15 hit point more attack, and that only costs 25 rounds. To me, that's so cheap, you just get it. And then that brings you up to 75 attack versus an 80 hit point unit. Okay, you get the next upgrade, and now you're dealing 15 hit point more. So you're dealing 90 hit points of damage versus an 80 hit point unit. So it is one hit kill. At that point, what becomes important is actually who moves into range first, right? If you have 2 units and they each take 1,000,000 hits to kill each other, then it doesn't matter who moves into range first. But in this case, it totally matters who moves into range first. Whoever moves into range first of the other guy is going to lose. But in Battlecode, if I'm not mistaken, your actions take place immediately, which means that if you choose to, what I did in my code is not smart, because look at this. Look at this. Here's the Mage code in Lecture Player 5, and it says, okay, if I'm not in the garrison, then if I can shoot, then go ahead and shoot. Otherwise, move. So in Microsoft Paint, do you already see what I'm trying to say here? I'm going to go through it anyway, just in case there's somebody who didn't see what I wanted to see. That's my current attack possibility, my range of attack that I could be attacking. Is there a fancy correct word for that? I think it's just called attack range. And maybe there's an enemy. So here's me and there's the enemy. So if I'm in this exact situation, then the way I've written the code is I check to see if I can attack something, and I can't in this case. So then what I'm going to end up doing is I'm going to move forward. Okay, so I'm going to copy this, and I'm going to make it transparent background. Oops. And then I'm going to put it here. Okay, so then I move forward. I move forward, and that's the end of my turn. I stopped. But you know in Battlecode this year you can attack and move in the same turn? I'm sure you knew that, or maybe you didn't. Now you do. So what I ended up doing is I moved forward, and then I conceded the turn, I ended the turn, and now the enemy is going to hit me. And you might say, well, what difference does it make if the enemy hits you? You'll get him next time. No, you won't, because he's going to hit you. It's one-hit kill after 100 rounds. And the match is going to last long enough. If somebody's getting mages, they're going to go for that, right? You got to think they're going to go for that so that it can deal 90 damage. That makes a world of difference. You have no recourse. You can't retreat. You can't heal. I mean, if you did 90 damage, you'd kill the mage in one hit. You get the next upgrade, you can kill the healer and the worker in one hit. That's a pretty big deal. So I feel like people who go mage are going to totally get those upgrades. And then it's really going to matter who steps in first. And after all, even if you step in, even if it isn't a one-hit kill, if he's got 2 guys, so imagine he's got another guy here, firing squad style. This Battlecode always gets dark. I don't know why. Just it always feels like we're talking about something horrible. Then, of course, it doesn't matter that he doesn't have one-hit kill. It'll effectively be. And you can also imagine the scenario. I think you can imagine the scenario where you've got a choke point, and you block the choke point with mages. And of course, those of you who are familiar with rangers know that this wouldn't work because rangers are counter to mages. They have a longer attack range. But just humor me for the moment here, and imagine that that each of these guys is going to shoot, and it's going to deal damage in an area about that big, right? Because it's 2 tiles each. So that's the attack pattern from this mage, right? And then there'll be another attack pattern from the next mage down. Do you see where I'm going with this already? Do you see where I'm going? So then there's another attack pattern from that guy, and another attack pattern from that guy, and so on. So you can see that the actual hit, the actual hit number, as you go down this this attack pattern, if they're all just blindly attacking ahead of them in a row, then the amount of damage that's being done to a given tile is, you just add up the number of overlapping squares. This is theory crafting at its absolute best. So there'd be 1 there, 2 there, and then there'd be 3s all the way down. I think, did I do this wrong? Should this be a 3? That should be a 3. No, that's definitely a 1. Because that only, I think I might have done it right. Anyway, you get the point that they overlap, and so you really, you're never going to get past that. So if you're really smart about who shoots first and who moves when, it'll make a big difference. That's the whole thing I wanted to say. I don't know why it took me 20 minutes to say it. It wasn't 20. It was only a little bit of time. So I think I'm going to move on to the next part. Unless there's questions, I'll just pause for questions for no reason. No, there's a reason. Okay, I'll move on. So you're probably dying to know, how effective are rangers? I mean, okay, the 2 of you who haven't already figured out that they're pretty darn good are dying to know. And I won't have that in my lecture hall. You're not allowed to die in here. So I'm gonna get number 6 going here, and we'll look at lecture player 6, which will be in blue, versus lecture player 5. I think I have to kill the manager and start over again because it seems to have stopped. Huh?
No murdering.
No murdering. Absolutely. I'm going to pause the manager. Right. It's even worse than eating food in the lecture hall, if you can believe that. Okay, so we were going to look at 5 versus 6. Speaking of food, how's the food coming along?
It should be here shortly.
It should be here shortly. That's always a good thing. Okay, so we've got 5 versus 6, and 6 is the one that should be building rangers. So there, the blue player just built a factory, another factory. I expect to see a ranger pop out. There's an R. Okay, so we got rangers versus mages. And the rangers appear to be shooting at the mages. Okay, the mage managed to score at least 1 hit. When I watched this kind of match take place before, it was kind of one-sided. I'm going to leave that running on the right while I look at things on the left. I got the sides mixed up. Okay, so we see that the rangers are about as effective at destroying the mages, at least the way I wrote the code, as the mages were at destroying the knights. And I don't think it's going to be a rock, paper, scissors. I think it's going to be one-sided all the way down. So we'll just double-check that. We'll put attacking knights, lecture player 2 versus lecture player 6, just to make sure it isn't a rock, paper, scissors condition here. And I might see how it says here, permission error, it can't access the file. I think that means that I want to restart the manager. So I'll just go ahead and restart the manager. And we were going to do lecture player 2 versus 6, just to make sure that the knights don't beat the rangers. I mean, this sounds like a sporting thing. Those are probably football teams or something. Okay, so in the blue team, I think we're going to see knights. There's the Ks. And they should be going out and fighting I said the wrong thing. The red guys are Ks and the blue guys are Rs. And you can see the Ks are hitting the Ws. And you never want your Ks to hit your Ws. But the thing is, the Ws are pretty resilient. I mean, they got 100 hit points, and if you run low, they're gonna build more. So it's not gonna make much of a difference. So yeah, to me, it's not a compelling argument in favor of the Ks. They don't even make it close enough to hit the Rs. What an embarrassing circumstance. So I think you can see that it's not a rock, paper, scissors, at least the way the game is balanced right now, and that Rs are just pretty darn good. So has anybody gotten the snipe mechanic to work? I was trying that earlier today. I was trying to get them to snipe, because that's a ranger ability. If you upgrade it, they can hit any tile on the map. I thought, sweet, I'm going to sit back, turtle, build rockets, and pew pew all day long. I wasn't able to make it work, but I'm going to keep trying. And if I can demonstrate that it doesn't work, then we can make an argument that it ought to be fixed. I don't know. What about people in chat? Anybody in the chat figure it out? I haven't programmed rangers low, only knights. Feels bad, man. They will be buffed eventually. Mage buff. Max, please move cam a bit to corners. Battles are kind of blocked. Okay, hopefully that helps. Thanks for everybody's comments in the chat. Okay, let's move on to the next example. We're burning through these examples as if they were different from one another. So let's see here. The next one, what did I even do? Let's get it running while I try to remember. I mean, it's hard. It's hard to. I should probably have a better naming convention than just putting a digit after the word lecture player. So this is presumably a different piece of code. Aha, yes, I recall. I recall at least something about it. I think it has to do with the positioning of the rangers. Recall what I said about the mages, that it really matters who comes into range of the other guy first? I thought maybe the same thing is true about rangers, that whoever takes the hit first by walking into attack range is the one who's going to lose the battle. After all, previous years of Battlecode have often come down to a kind of stalemate. There will be two rows of enemies, and they're both at each other's maximum attack range, and whoever steps out into the DMZ between them gets annihilated in short order. So in this case, I think the red player was 6 and the blue player was 7, and the red guy won. Well, that doesn't speak good to the improvement of number 7. Let's see if it was 7 versus 8. Let's see if it was 7 versus 8. So let's look at number 7. It says, here's the ranger. He checks if there are any attackable enemies, okay, and he tries to move somewhere, but there's a specialty here. In the fuzzy go-to, I checked in fuzzy go-to to see if dmap.get equals 0. So here, instead of preparing a map of areas which are good to shoot at, now I'm flipping it around. I'm preparing what I call the danger zone map, in which I draw a disk around any enemy that's equal to its attack radius. So then I had two thoughts about this. One thought is, okay, you can draw a danger zone map, and there's an example of such a danger zone map down here. I have it print at one stage during the combat, and you can see that there's heavy danger at this Venn diagram center with the 5s, and low danger at this region here with the 1s. And you can see that this diagonal line here is exactly the same as this diagonal line here, which develops over the course of the fight as rangers decide not to put themselves in harm's way. And this is another reason why, you know, if you get to a map and you end up having a stalemate situation like this, that having the snipe ability would be such a big game changer, because then you could still break through that defense. So the game has in the past, Battlecode, many years, developed into a state where there will be a series of parallel lines, and then it can come down to one team making a decision. Like whether one team wins or loses can be whether the team makes a decision to go ahead and attack into it knowing they have a superior numerical advantage, or the game ends because somebody reaches a victory condition, which in this case would probably be heading to Mars, although that kind of decision is going to have to be one that we discuss in a later lecture video. So thanks for coming to this one. The food is it ready yet for them to get? It will be ready in a few minutes, and I'll let you know as soon as it's ready. So thanks very much. I didn't know anything about it.
Okay,
Shall I go ahead?
That would be an awesome announcement. It's being pushed back by 24 hours. Its submission deadline will be 8 p.m. tomorrow.
Got it. I have an announcement to make about the sprint tournament. We are pushing back the submission deadline. All right, push it away. Push it away. Push those problems right away. So we're going to push it back by 24 hours, which brings it to 8 p.m. tomorrow, I believe. So thank you for your patience, and I think you've got a chance to make your sprint submission that much better. All right. Is the food ready? Can I get a thumbs up if the food is ready? I got a thumbs up. So you guys can go get some food. MCDG2 asks, can I see the add disk method? Yes, I will show it to you.
Are there plates or no?
And here it is, the add disk method. Pretty simple. I'm not sure, Supa Troopa. I'm not sure who would win, because after all, Red has an advantage, but they'll take some damage when they're moving forward. I think they would win. I think they would. Not sure.
Yeah, it is. I'm finishing my and then we can actually start doing coding. Remember, sprint turn doesn't matter. All sprint turn gives metagame. Basically, metagame is the how and whatever it is. Yeah, it's sprint turn doesn't matter. I think I missed the sprint turn first round. Except for last time.
And the only thing is that there'd be submission deadlines before that because the actual
Bye-bye, Twitch chat.